So May semi-scale sales up 19.8% year over year, and says the SIA. So May chip sales were up 19.0% year over year at $59 billion compared to the $49.2 billion of the May 2024 and up 3.5% in the $57 billion of April 2025, said the SIA. The global conductor sales remained strong in May, edging above the previous month's total of remaining well ahead of sales from the same month last year, said the CEO John Neuffer. As growth in the global chip market continued to be fueled by strong demand in the Americas and Asia Pacific or other regions. Regionally, the year-to-year in May sales up in Americas 45.2%, Asia Pacific or other 30.5%, China 20.5%, Japan 4.5%, and Europe 4.1%. Month-to-month sales in May increased in Asia Pacific or other 6.0%, China 5.4%, Europe 4.0%, and the Americas 0.5%, and Japan 0.2%. Okay. Tata Electronics sparks India's chip revolution with the first ever semiconductor plant. Tata Electronics has officially started building India's first semiconductor fabrication unit at Dholera near Ahmedabad in Gujarat. This ambitious project values at 91,000 crore, the rupees, is being developed in a partnership with Taiwan's Power Chip Semiconductor Manufacturing Corporation, PSMC. The plant is expected to roll out its first batch of the chips by December 2026, marking a turning point in India's journey toward technological self-reliance. What is a semiconductor, and why does India need a fab? The semiconductor is a material, typically silicon, that can conduct electricity under certain conditions, and it is used to make microchips. These chips are at the heart of all modern electronic devices, from smartphones and laptops to cars and industrial machines. India, until now, has relied almost entirely on imports for semiconductors, making its industries vulnerable to global supply disruption and price fluctuation. The recent global chip shortage exposed the risk of the dependency affecting the Indian manufacturers across sectors. So by building its own semiconductor fab, India aims to secure a stable supply of chips, reduce import bills, and support its growing electronics, automotive and defense industry, and this move align with the government Atmanirbhar Bharat vision, aiming to making India a global hub for the electronics manufacturing. Economics, impact, and benefits. The Dholera fab will have the capacity to produce up to 50,000 wafers per month, catering to the sectors like automotive, computing, and communications, and artificial intelligence. The project is expected to generate more than 20,000 direct and indirect skilled jobs, is creating the opportunities for engineers, technicians, and support staff. Tata Electronics facility will anchor a broader semiconductor ecosystem in the region, potentially leading to over 1 lakh jobs as the supply chain and ancillary industry develop. Local chip production will help Indian manufacturers access reliable and affordable semiconductors, so making India's products more competitive globally. It will attract the further foreign investment and foster innovation, as startups and MSMEs gain easier access to advanced technology. The government support and provisions. The Indian government, through the India Semiconductor Mission (ISM), and has committed to provide 50% fiscal support for eligible project costs, significantly reducing the financial burden on Tata Electronics. The government is also playing a crucial role by facilitating the construction of the 1,500 residential units for Tata staff, suppliers, and expatriates in Dholera, ensuring that skilled professionals have a quality housing near the plant. So Dholera Special Investment Region offers robust infrastructure, including reliable power, ultra-pure power, expressway connectivity, and proximity to the upcoming Dholera International Airport. The state's semiconductor policy provides the incentive like a 40% capital expenditure subsidy and land support, and making it attractive for high-tech manufacturing. So in addition to the Gujarat fab, Tata Electronics is expanding with a semiconductor assembly and test facility in Assam, further strengthens India's semiconductor ecosystem. India's first semiconductor fabrication unit by the Tata Electronics is a historic step. It will not only make India self-reliant in critical technology sector, but also drive economic growth, create jobs, and have the country emerging as a key player in global technology landscape. Okay. DAC 2025 Design E-Times is the design lines, AI and big data design line toward the multi-agent system in EDA, San Francisco, California. At DAC, EDA vendors showcases their visions for the future multi-agentic system that can handle the greater portions of the EDA workflow autonomously. During his Monday keynote, William Chappell, Vice President and CTO for Strategic Missions and Technology Divisions and Microsoft, showed advanced in-agentic workflow for scientific researchers and development from the company. This example shows a task manager agent asked to come up with an approach to developing a vaccine for a particular disease. This agent was able to understand the assignment and reflect on whether the task was executable. If not, it could break it down in further steps and call other agents to reason and implement parts of a scientific method. These agents were able to make hypotheses, code tools, and to gather the relevant information, generate a short list of the possible proteins, and analyze their efficacy. The task manager agent collected output task logs from other agents, and if it judged that they failed their tasks, it could ask them to start again. The tools being called could be existing software tools or could be generated by the agent, which have the ability to write code. So the result: 8 new vaccine candidates were produced in hours. Agentic workflows to do a much better job of complex tasks like scientific research and developed than a single LLM would on its own, Chappell said. The same ideas can be applied to the chip design, where Microsoft and Synopsys have been collaborating on a multi-agent system. Biology is hard, but partly because it's relatively sloppy and there is a bunch of biology and humans that are interacting, which are unpredictable. Chopper said, chip design is about precision and rigorousness, but we have to that with the workforce shortage. And this is a prime area to really read the way in this field. An overview of a multi-agent silicon design system shown by Microsoft William Chappell shows EE Times. Chappell broke the chip design process into 3 chunks: intent to spec, spec to RTL, and RTL to networking. All 3 chunks used a combination of generative and validation agent. For example, the first chunk generates a spec sheet, which is passed to the spec RTL workflow. This workflow has behavior to RTL agent, test generation agent, static timing agent, and validation steps to verifying what produced is good enough. While this is science, this very much maps onto the wheel of discovery. Chappell said, how do you discover the design? How do you validate a good design? In this case, how do you map your spec or your intended to architecture? Does this step model match that intent? What are the test suite insertion and simulation and emulation, and then test result assessment? And the agent can keep going as long as you've something and you've evaluate whether you are going to the right direction. And you can go for as long as you like. As overall, the Chappell said multi-agent systems are usually opportunity for EDA. This is something where you have to hype cycle happen, and then you will have capabilities that are real coming out the other side. He said, I think 2025 is going to be a year of figuring out how to integrate these agents with a human product. Challenges for agentic AI. At a private event hosted by Synopsys and Microsoft, a demo video shows the company's vision for a spec to RTL system, RTL agentic workflow. This vision for this system comprising the Synopsys EDA agent plus Microsoft Planning agent on Microsoft Discovery Agent R&D platform that will be to iteratively figure out the wrong EDA tools and a region of the results to verify and optimize them. Such a system would still require the human in the loop though. In panel discussion at the same event, experts discussed at the current state of agentic AI in EDA. Siddharth Garu, Institute Associate Professor at New York University, said that generative AI for hardware design is behind each software code writing peers. We are blind because data is scarcely available in the public domain. As Garg said, I also think the hardware engineering tasks are fundamentally more challenging. The agentic systems are designed to optimize the real world. In the hardware space, metrics like power, performance, area, and routing congestion, these things are a lot harder to measure than real world in software engineering. Kaliwok Kochian, Executive Vice President for Solutions Engineering and ARM, agreed that getting hold of efficient data is the hardest part. The ARM started from the IP, moving to a subsystem and ecosystem enablement. It's hard to train these models. Every time I ask any of the models something, they point me to GitHub. He said, it would be interesting to see what some of the behemoth chip companies are doing. That's gonna be interesting because there are lots of data that they can train on. Other experts expressed that the caution is still needed to make sure the result of the agent design chips are reliable. Soumya Banerjee, Senior Vice President of the ASIC Design, CAD and Methodology at Marvell Semiconductor, pointed out that the cost of mistakes in chip design is very high. It's very tempting today with all these agentic things. You have an agent that goes and parses the report, figure out the critical path, and generate the histogram, puts it into a slide, send it out in an email, Banerjee said. But the worry there is if the engineers stop thinking about those reports and don't look at it, is what are they are going to miss. So I don't think we are at the robustness level today to sign off on it. The Banerjee also worried about how easy it has come to avoid looking at the fine details of what the tools are doing, so which could lead to a loss of skills, he said. The Ayman Josh, Vice President of Design Enablement and Automation at Western Digital, said the agent will eventually become the employees of the future. We found many times that junior engineers make a lot of mistakes, Josh said. Agents are very good at catching those mistakes, correcting them. There was an example where my team was showing me a 30 times improvement. I asked what happened, and it was a junior person. He had set up something wrong in his flow and never looked at it because its runtime wasn't that much. Versus people, agents can discover information very quickly and facilitate engineers asking architecture questions without having to hold meetings, which can speed things up. Agents also provided access to up-to-date data all the time, whereas the human team's information was frequently out of date, Josh said. So the Siemens EDA AI system. At DH, Siemens EDA launched its AI-enhanced toolset called the EDA AI system. While the company already widely uses machine learning, especially reinforcement learning, in its tools, the new system is designed to introduce generative and agentic AI into EDA workflows. Amit Gupta, Vice President and General Manager at the Custom IC Division and Siemens EDA AI at Siemens EDA, told the EE Times that the new EDA AI system acts as a front end to existing AI-enabled tools across Siemens' portfolio. The new system is a software component underneath of all of Siemens EDA tools that powers some generative AI features, but it also helps with the company's workflow, he said. One of our philosophies is that it's open, so if you wanted to tie it to a third-party tool that you want to bring into your own design data and not be limited to data that being generated by Siemens EDA tools, then the system is able to sit as a platform within the organization and be the central hub for AI and for generative agentic AI specifically. The feedback from the customers too far at DH indicated that the customers want to use a combination of the internally designed agent, third-party agent such as NVIDIA NIMs, and a Siemens agent. We talked to customers who have developed and made investments into their own internal AI system. Gupta said, "Great. We will plug in our system with your system so that they can coexist. We are not trying to replace any internal investment that you've made." Siemens EDA AI system will typically be deployed on-prem within organizations, following feedback that customers want to protect their data and don't want their data used to train tools that can help competitors. Some customers want to start down at the tool's feature level, some want to start at the entire workflow level, and some want to do both. And Gupta said so it depends upon the journey that each customer is on. And we are trying to show that what's possible and then to be able to provide value in those areas. Okay, next one is Computex 2025, the hardware industry. NVIDIA CEO Jensen Huang claimed that they have an option other than TSMC for chips, rules out the partnership with Intel and Samsung Foundry in the US. May 21st, 2025, in the NVIDIA CEO Jensen Huang has reaffirmed the company's commitment to TSMC, claiming that Team Green has no other suitable alternatives at the Taiwan giant. NVIDIA CEO said that TSMC's leader in a CoWoS and the advanced CoWoS, the advanced packaging technology which defied the Moore's law. The NVIDIA has been a key partner for TSMC for several years now, and the company has specifically deepened its cooperation after the initial AI hype. The partnership has evolved to a point where the Team Green CEO now said there is no alternative to the Taiwan giant, especially in the CoWoS department. Speaking at the GTC Taipei Global Press Conference, NVIDIA's Jensen Huang revealed that the company's semiconductor supply chain will rely on entirely TSMC in the near future, indicating that alternatives from the Samsung Foundry or Intel have worked out for them. When Jensen was asked whether the NVIDIA would consider a partner other than TSMC for semiconductors, especially in the US, here's what he had to say. This is a very advanced packaging technology. I'm sorry, we don't have any other choice at the moment. And pointed out that TSMC is still the only partner. Taiwan Economic Daily. One of the key reasons why the NVIDIA has managed to bring such high performance to the table is that the company has managed to defy Moore's law by integrating technologies such as CoWoS, since the packaging technology allows Team Green to stack multiple chips together, combining performance and bridging it to levels which couldn't have been done by node shrinking. Jensen claims that there is no alternative to the CoWoS, and based on the industry report, we know that TSMC holds the reins on the advanced packaging segmentation. Team Green was reported collaborating with Samsung and Intel and for advanced packaging, but it seems no deal has been formulated yet. Similarly, on the chip frontier, NVIDIA is a primary partner of TSMC and have been across the Apple when it comes to the valuation of orders placed with the Taiwan giant. Apart from this, NVIDIA has played a massive role in TSMC US expansion as well, being the major customer for companies' regional operations. And it is safe to say that NVIDIA TSMC partnership will go a long way, as stated by Jensen at the Computex keynote. And with the Taiwan giant expanding into US, Team Green will be free geopolitical uncertainties. Okay, next one is the GlobalFoundries announced $16 billion US investment to reshore essential chip manufacturing of solid AI growth. June 5th of 2025. Backed by the leading tech giant, the investment reinforces domestic semiconductor production in US-based innovation in AI-enabling and power-efficient technologies. Malta and June 2025, GlobalFoundries, Nasdaq GFS, working with the Trump administration, and with the support from the leading technology companies aiming to ensure critical components of their supply chain, today announced plans to invest $16 billion to expand its semiconductor manufacturing and advanced packaging capabilities across its facilities in New York and advanced packaging capability across its facility in New York and Vermont. GF's investment is a strategic response to the explosive growth in artificial intelligence, which is accelerating demand for next generation semiconductors designed for the power efficiency and high bandwidth performance across data centers and communication infrastructure and AI-enabled devices. GF is collaborating with major technology companies such as Apple, SpaceX, AMD, Qualcomm, and Technologies in NXP and GM that are committed to the reshoring semiconductor production in the US and diversifying their global supply chains. So these companies partner with the GF to support their production of US-made chips, underscoring GF's role in the trusted suppliers of essential semiconductor and a key enabler of supply chain security. At GlobalFoundries, we are proud to partner with pioneer technology leaders to manufacture the chips in the United States, advancing innovation while strengthening economy and supply chain resiliency, said Tim Berlin, the CEO of GlobalFoundries. The AI revolution is driving strong and durable demand of the GF technology that enables tomorrow's data centers, including GF leading silicon photonics, as well as GaN for the power applications. Meanwhile, that GF's proprietary FDX technology is uniquely positioned to support AI functionality with low power consumption. With all these technologies and more manufacturers right here in the US, GF GlobalFoundries is proud to play its part in accelerating America's semiconductor partnership leadership. So, the GlobalFoundries investment is a great example of the return of United States manufacturing for critical semiconductors, said the U.S. Secretary of Commerce, said Lutnick. President Trump has made it a fundamental objective to bring semiconductor manufacturing home to America. Our partnership with GlobalFoundries will secure the U.S. semiconductor found's capacity and technology capabilities for the future generations. The rapid rise of AI in both cloud and at the edge is driving the adoption of new technology platforms, the 3D heterogeneous integration technologies. These advanced solutions are essential to meet the exponentially growing requirement for power efficiency and bandwidth density and performance. GF is uniquely positioned to lead in this space with the 22 FDX and silicon photonics capabilities in production in New York and advanced development of the differentiated GaN based power solutions in Vermont. So the GF investment builds upon the company's existing U.S. expansion plan, including more than the $13 billion to expand and modernize its New York and Vermont facilities, and funding for its recently launched New York Advanced Packaging the Photonics Center, the first U.S.-based facility located as of including the fundamental in the recently launched New York Packaging and Photonics Center and the first U.S. facility of its kind dedicated to silicon photonic packaging. GF is committing the additional $3 billion, which includes advanced research and development initiative focused on packaging innovation. This investment represents $16 billion, which includes advanced research and development initiative focused on packaging innovation. silicon photonics and next generation GA technologies. And aggregated the investment of the